Before I discuss question C or part C, let me have a little correction here because I don't want to redo the video, no? Hago kayo mag-usab-usab og video. So in part B, take note, this is velocity when time is 2. Kasi yung sinusolve naman natin dito sa last part is instantaneous velocity when time is 2. Okay? So ito yung sinasabi ko na iba yung nasa mind ko sa sinusulat ko. So this should be velocity when time is 2, velocity is when time is 2. Okay? It makes sense. Now, let's go to part C. Si part C is asking of the sketch of the trajectory of the dot. So, trajectory means the actual path taken. Imuhang i-draw ang iyahag yung giagian. So, remember, the moving particle here is a dot in a screen. So, pag sinabing trajectory, meaning, ano yung path talaga, actual path na dinaanan ng particle mo. And there's another requirement here. We are not just to sketch the path of the dot, but we are also to show the velocity vectors that we're able to solve in part B. Okay, how do we do this? We go back to R as a function of time. Ito. Ayan. So, for you to sketch the actual path, kailangan mo yung position sa x-axis, position sa y, at saka kung 3-dimensional ito, position sa z. But in this case, 2D lang, no? Kasi screen lang man sa computer, no? Kung 3D yon, edi holographic na yon. So in this case, we will just show, tabulate the values that we can easily get, no? So, for time 0, 1, 2, okay na siguro ito, makasketch na tayo ng path nito. So, what is the x position when time is 0? Focus ka dito. Ito, magsi-0. So, ang matitira, 4 ay hat. Kaya, this is just positive 4. Okay. What about the y? 5, 0, 0 na kaagad yan. When time is 1, this becomes 6.5 positive. Si y, 5 times 1, positive 5. And then finally, when time is 2, na-solve na natin to kanina. This is 14 positive. And then si y is, of course, 10. Positive 10 centimeters. So, in your graph now, iba na naman ito sa position time, iba ito sa velocity time, because this is a sketch of the trajectory. So, pag trajectory, talagang this will always be the x-axis and this is the y position. In this particular problem, the unit here is centimeter. Okay? So, ang point natin, obviously, ito, yung coordinates ni point 1, coordinates ni point 2, coordinates ni point 3. So, ipa-plot lang natin. Positive 4, 0, y. So, if this is 1, 2, 3, 4, andito yung dot natin. So, kung ang screen ito, pag start ng timer, naadiha ang ato ang dot. And then, in your trajectory, in your sketch of the trajectory, ilalagay natin yung element of time. So, this is where the particle is. Lalagay natin when time is 0 second. Tama ba? Okay. Let's go to the second point. Positive 6.5. So, if this is 6, 7, 8, 9, 6.5 is somewhere here. And then, partner niya si 5. So, 5 is somewhere here. Ayan. So, this is now where the dot is. And this happened at 1 second. Tama ba? Let me get my ruler. So, you have 6.5 in the x and then around positive 5 in the y. Finally, positive 14. So, let's say 11, 12, 13, 14. Ito. And then, I'll go 10. So, nagamit na tayo ng ruler. And then, 10. Ayan. So, this is where the dot is. Pagpatak ng 2 seconds. So, obviously, our best fit line here could be something like this, a parabolic curve. More or less, best fit line, oops, there. So, as time goes by, this is the actual path taken by the dot. So, nilihok ang dot na to. From 0 to 2 ni ana siya. Following the the script of the web designer. Okay, so we are done now with the sketch of the path or the trajectory. Ilalagay na lang natin yung velocity vectors natin. Okay. In part A, we were able to solve that velocity 1 times 0 has 5j hat. Yung value niya, 5j hat. So, 5j hat, pag nag-sketch ng velocity vector, I hope you've read in the notes, velocity vectors are always drawn tangential to the path. So, it's always a tangent line. It's a line that touches the path of your particle at that particular time. So, at 1, 0, you have 5 centimeters per second going positive y. So, pag sketch natin siya ngayon, more or less, this is now your velocity vector when time is 0, and it's 90 degrees kasi it's going towards the y direction. So, tama siya. In this case, it's very obvious na the velocity vector here is really tangential to this path at this particular point. So, pag tangent, diba, sa labas ng curve natin siya idodraw. Let's go to velocity when time is 1. So, if you look in your notes, instantaneous velocity vector when time is 1 is 7.1 centimeters per second at 45. So, how do I sketch that? Doon ako ngayon sa path ko. Ito. Gagawa ako ng, sorry ha, gusto ko i-hit ito. Ayan. So, gagawa kayo ngayon ng maliit na guide na Cartesian plane. So, maliit lang na guide dyan. This is your y. And this is your x. So, more or less, kalahati ng 90-45. So, more or less, para tangential pa rin. And I have to draw this arrow, obviously, longer than this one. Kasi ito, this is just 5j. Diba? This is 5j hat. Whereas ito, this is 7.11. Ito yung na-solve natin na 45 degrees. And then, the value here, the magnitude is 7.11. So, this velocity vector, that's your drawing for the instantaneous velocity when time is 1. Tama ba? Okay? Or, pwede pala nating isulat ko na lang muna dito yung sa table, yung velocity. This is in centimeters per second. So, this was 5j hat. Dito naman is 7.1 at 45 degrees. And this is 11 centimeters per second at 27. Yung sinolve natin kanina. So, pag sketch ko ulit nito, velocity when time is 2, make another small Cartesian plane with the particle at the origin. And then, 27 degrees more or less if this is 30, 60. So 27 is somewhere here. And then longest line. This is now the velocity vector when time is 2. Na-solve natin. Ang magnitude dito 11 cm per second. And this is around 27 degrees. Ayan. So, I hope it's clearer now that when you sketch the velocity vectors, it's always tangential to the path. Okay? Number 2, you can always put a small Cartesian plane as your guide sa point kung saan naandoon yung particle mo. Okay? So, there are several problems in our main references. So, I hope you'd also solve problems on your own before looking at any available solutions. Okay? Thank you.